Hello, my name is Rich Howard, owner of Architectural Builder Supply. In this video is to bring you a closer look at the HES, or HES 9500 series electric strike. The name HES is synonymous with electric strikes, and I remember when they first gained notoriety in the marketplace, what I recall mostly about them was the interchangeable faceplate scenario, where you could literally handle a multitude of different locks using a single, that 1006 body. And their name has been synonymous with good quality strikes ever since that time. A couple of decades ago would be my guess. I had one problem with a HES strike in all that time, and client called up irate, rightfully so. Employee entrance of a factory. The strike was not releasing to let people in. Third shift scenario. Saturday, third shift. I get the call. I go the 40 miles away. And for some reason, the bottom trigger was releasing, but the top was not. Started to dawn on me that it might have something to do with gravity, and of course it did. I then took my voltmeter out, which you'd think would be the first thing you'd do, but it wasn't in this case, because I was just puzzled by it. New installation, mind you. Worked for a couple of days, strangely. Said to the, called up my client, who I of course couldn't get on the telephone, to find out where is the power coming in, because this building could have been, it was likely 90,000 square feet. Come to learn with my voltmeter that there's not adequate power being supplied to the strike, and that bottom trigger was working because of gravity, and the power supply was so far away. No failure of the HES strike, naturally. Got to follow the distance gauge of wire in order to make a proper installation. The point of all of this is I have no reason not to recommend HES strikes. In my opinion, they fit in a very good middle ground of very high quality, yet not the most expensive strike that you're going to find. This video is going to be broken up into several components. The first is going to be a technical summary of it. It's a UL10C fire-rated 3-hour strike when you're using it as a fail secure installation, meaning when the power is cut, you're going to have a locked condition. NFPA 252, ASTM-E-152 fire door compliant, along with CAN 4-S104, UL 1034 burglar resistant as well, listed and suitable for outdoor use. Classified as grade 1 by BHMA. And finally is ROHS compliant, restriction of hazardous substances in its manufacturing. This unit's standard features means that it's going to install in a hollow metal frame onto a hollow metal frame, a wood frame as well, separate base and decorative cover plates that allow for easy adjustments, stainless steel componentry, has a substantial static strength rated at 1,500 pounds. Which is, you know, stronger than most electromagnetic locks. Dynamic strength of 70 foot-pounds. They call it a grade 1. Its endurance is at 500,000 cycles. Keep that in mind. Field selectable for both fail-safe or fail-secure. Field selectable for 12-volt DC and 24-volt DC. It's non-handed, this unit. Is horizontally adjustable and has a 5-year warranty. Low amps, if you're running 12-volt DC, it'll require 0.45 amps, and at 24 VDC, you're at a quarter amp. And power over Ethernet friendly, and a slew of different options can be done with this, such as LBM, which is latch bolt monitoring, which is important because you don't want someone to tamper with the latch bolt of the installation to bypass. The latch bolt strike monitoring is possible as well. That will basically tell you if it's present within the keeper, and is available in lots of different finishes. The next part of this video is going to go into a visual review of the item. Okay, and now we're going to continue with a visual tour of the 9500 series strike. And really the only thing that you have to worry about when you're doing this type of strike is if you have an existing installation, you just have to be mindful that the strike and the back set of the exit device on the door are going to be compatible. You'll want to refer to the template, meaning, you know, as you know, the back set of the exit device is dependent on the strike type that you're using. And most manufacturers will only have kind of one strike that you would use, let's say with a rim device. Some others have more than one strike that can be used. And then when you get into using an electric strike on any of those installations, the dimensional properties of the back set simply change. So before you buy this to find out that you really can't fit it into the installation, you'll want to refer to the template before doing so. Okay, visual tour is next. We're going to go into the dimensional properties as well. That's a heavy scalp plate there, and obviously one nice thing about this is you're going to be able to swap that out for a variety of different finish types. Sits down nice and secure. Obviously the only thing you're going to really have to accommodate is that power coming into it. Pull that cover off. That cover's heavy, there's no doubt, and that's all stainless steel on the 630 version. You can see where my prior trouble was occurring with my triggers not opening together, but a very simple type of strike, very petite and elegant in its design. Very elegant in its design. That's a hallmark of the Hess line. Let's go over the dimensional properties, and I'll set this aside because, well, no reason to do that. We'll measure all of it at this time. Okay. Overall thickness, you can see you're right at 1/2 inch. With an overall height (9 inch), with an overall width about 1 3/4 inches. Okay, you're going to get a couple of typical fasteners for steel and for a wood installation. Those 4 small screws that you see in there will be to simply hold the scalp plate onto the body. Okay. Allen wrench is intended for adjustments, which we're going to get to in a moment. Your ability to wire this in either 12 or 24 volt requirements. Both are common. Obviously, if you're doing maybe some sort of an intercom scenario, you might be looking at 12 volt, but I really think 24 volt is by far a bit more common. So we've got our visual tour, we've taken our dimensional properties. Now the next component of this video is going to get into the installation instructions, and those are of course linked to down below. And one thing that I've always liked about Hess is their paperwork, while there's 4 pages to it, you know, 1 page is a template, so that doesn't really, you know, need to be counted. The primary page is usually like, here's what's in the box. So you really only have 2 pages that you have to deal with. One thing that I've always appreciated about the Hess product line. So let's get into a review of the installation instructions. Okay, now the next portion of this video, we're going to go over the electrical specifications. We have already talked about the amps, although there's a small amount of difference. The installation instructions say that at 12 volt DC you're going to be looking to require half of an amp. Resistance 24 ohms, and then at 24 VDC it's 96 ohms. There's also a chart which gets back to the original problem that I had with that first installation, is the distance and the wire gauge. If you're dealing with 200 feet or less, you're going to be at 18 gauge for 12 volt DC and 22 gauge for 24 volt DC. 2 to 300, 12 and 24 respectively, 16 gauge and 22 gauge. 3 to 400 feet, you'll be at 16 gauge and 20 gauge for 24 volt DC. Getting on to page 1 of the installation instructions, I think what a lot of people like to do first, and I know that's what I like to do first, is really possess a solid working knowledge of the strike in terms of what I expect it to do by the time I get it all wired up and powered up. The very first thing you do, however, before you really do anything, is make sure that you've got proper voltage amperage coming to the opening. Before connecting any device at the installation site, verify input voltage using your voltmeter. Many power supplies and low voltage transformers operate at higher levels than listed, and if you have a rating that's 10% greater than the what the solenoid is rated for, per what we've already discussed, don't proceed. Correct that problem first, and then proceed once that problem is solved. We're going to talk about the wiring, a base model with and without the connector. We're going to talk about wiring it with options, the LBM, LCBM options, LBSM, forgive me, LBSM and LBM options. We're going to talk about switching the state from normally fail secure to normally fail safe, and we'll discuss that at length. We're going to get into talking about how to change that. And then finally, we're going to talk about the physical properties of the strike as it relates to the exit device that you'll install. So first, simply, you're going to, if you have connectors present, and not that you necessarily will, but you probably do, you're simply going to use those connectors. If you don't, there's a legend down below of what you're going to wire together, and that's literally on your installation instructions. Okay. So in the absence of connectors, you can see the 12 and 24 volt possibilities. Red and violet you'll tie together. Black and red / green you'll tie together for your negative. You can see what happens on your 24 volt. Violet and black go together. Then your red green will be negative. And all of these are identified here. Red. It's really handy to have a set of glasses. Very simple, very straightforward what's got to be done here. They've got red, red, green. Let's take a closer look at that. Yeah, so I couldn't see it without the cheaters there, but you've got a green stripe on that red wire. So that's your red-green. You've got your violet, red, and black. Now, you've got your connectors. You don't have to worry about any of that. If your strike has an LBM or an LBSM, you're going to have more wires, basically. And that's going to be called out in terms of how you're going to connect to your reporting console, whether you're connecting it to a light or whatever the case will be. Orange and green, normally open, normally closed. Same thing for your latch bolt status monitor wiring. Common, normally open, normally closed wires there. So why would you need to know that stuff? Well, a nurse's station in a senior citizen's home, be very handy to know the condition of the stairwell door, so that you'll know if it's opened or if the strike is tampered with. And that's why that's a reason why those provisions are made on an electric strike. So that will cover the wiring. Very simple, as you can see. We're going to now get into next talking about the fail-safe, fail-secure orientation of the strike. Okay, now we had mentioned earlier that the Allen wrench inside of the package would be for adjustments. And indeed, of course, it is. And I'm going to poke that out of the packaging here, and we're going to take a look because we're going to discuss how to change the state from fail-secure to fail-safe. If you're not sure what those terms mean, focus only on the safe or secure. Fail-secure, fail-safe, secure and safe, secure and safe. Secure, like, would be locked. Safe would have to be the opposite, unlocked. Think of it in context of this, because this is how the definition is. When the power is cut, what is the state of the lock? So here's the test. There's obviously no power. The triggers are locked. That can only be what? Fail locked, fail secure, secure and locked. So the way that that's governed on this is by these two little posts that are referred to in the installation instructions. This one here, and then this one here, right at the tip of my fingers. Forgive that homemade Band-Aid. Okay, so you have to reposition those to affect the condition. You want fail secure, certainly, if it's fire rated. Absolutely. However, there are times when fail safe is what you want. A condition of fail safe, no power. You might have no power. You might have a situation where the unit is always energized, but because of the requirements of the opening, you need to be able to enter the space. There could be some machinery that's operating that during normal hours or during all instances, the strike is energized. However, should the power go out, you need to be able to access that space. Also, instances where the fire department wants a specific sort of installation to occur, they might have fail-safe, like, for instance, the front of a commercial, the front of a residential building, like the outside door. They want to be able to enter if there's a fire, and if that strike is fail-secure, meaning that there is a locked condition upon loss of power, which would be normal, they don't want to have to break the door down, and you'll appreciate it too if it's your door and it's a false alarm that the door has not been broken down. So what I've done is I have reversed the position of these two posts here. I've simply shifted them from where it was installed to where it is now installed here, from here to here. Now that will allow me the condition by which there's no power and these triggers are now in an unlocked condition. And we can study how that works because the articulating arm that's up here is no longer held captive by the bar, keeping it in the locked position. So if you want to study that position right here, I will move it back to its fail-secure condition. Maybe we'll send it to the client with one of each. No, we would never do that. That's like the instructors who teach basic electricity in classes. They like to test you with funny little crazy things. Now it's held captive because that bar has been moved to prevent the limitation of this release bar. And we need to switch the other one back to where it was because the installation instructions say that from the factory this is going to come in a fail-secure condition. And all I'm doing is removing these posts that are what govern that operation. Very simple, and the very simple has always been a hallmark of the HES line of electric strikes. So we've got that all reversed back to the way it was. Now it's exactly how it was, fail-safe, fail-secure. you're most likely going to install this as a fail secure. That's just most likely what you're going to do, because that's by far the most common. But again, by no means is it all of the installations, okay, that you will run into. So be mindful of that. Now, installing the strike is going to be just simply, you've got these two bolts, you'll have two large bolts in the package. That's what's going to mount the unit through the two slotted holes. You're going to drill, and then you'll be able to laterally adjust the strike so that you're making proper contact with the Pullman keeper of the rim exit device, and that it's fully extending when it's coming closed, retracting, and then snapping back into the locked position. You want that perfectly placed. The slotted holes will allow you to adjust for any sort of misalignment, or if that drill bit walks a little bit. Being a machine thread, obviously they're inferring that you are going to drill and tap those holes. And these are, it might be 1032, but I don't recall. Definitely not. Quarter 20. Quarter 20. Now, there's also what's called a lockdown screw in here, which is that sole screw right at the tip of my finger. Obviously, those are slotted holes, so you could make that strike move a little bit, except, of course, if you marked and then drilled for this hole here, that lockdown screw would help provide additional security, any sort of lateral movement. And then again, the only other screws that are there are those four short ones that are going to hold the scalp plate onto the body itself, into the four holes that are here on both sides, top and bottom. The balance of the installation instructions really move us to the page 4. Be mindful that if you're going to install the lockdown screw, don't drill that with the strike up on the frame. You don't want to break that drill bit and then run your whole tool into that. Mark all the holes, drill and tap all the holes where appropriate. That would be a really good idea. Then, of course, you're going to drill one or the other of the wiring holes. You won't need both. They're showing both just because of the possibility for left-hand reverse versus right-hand reverse. 1 1/16 diameter access for that. You want to get in there and deburr those holes as well. Sand it down smooth. You want to have a smooth aspect over this rubber-coated section of 4 screws that are here. Now, the dimensional properties that we were talking about in terms of your back set, we had given you the thickness of the strike prior. Let's review that again. So we're looking at basically 13/16. Now, from the inside of the strike cavity to where the triggers are, you can see that you're about 11/16. So you're going to have to compare the requirements of your panic device against the installation instructions that come with that regarding back set, and then proceed accordingly. Make adjustments. If you have and where I think you really need to be careful is if you want to add an electric strike to an existing installation, which is very common. I've had people that said, yeah, send me that electric strike, and the problem becomes at that point, well, what's the back set? How much room do you have between the stop and the head case of the exit device? And you might have a blade stop or a very small projection strike where the back set's quite small, and you physically can't fit the strike between the stop and the head case. So you don't have enough room. And if it's an exit-only device and it's not through-bolted, probably not a big deal. You can shift it over the small amount that you'll need to shift. And if it's a new installation, then you're in good shape. You've got the dimensional properties. You can get the strike installed, properly wired, get the strike installed, and then just physically mount the exit device according to field conditions and what works best. Hess also has, for their strikes, shims. Now, I don't know if they have them for their 9500, but let's take a look and see if they do. And I've been able to confirm that there is, of course, a spacer plate, which is the 9000-108. And the 9000-108 is, I'm going to say, is an 1/8 of an inch thick, but I do not recall, so we're going to look it up. Available in black or stainless. It is an 1/8 of an inch. I've been able to confirm that. Black or stainless is what it's available in. You can do a surface mount style box should you need to. Obviously, if you're running it with AC voltage, and now we're at the end of the video where we're going to talk about the particulars, let's say. Plug-in bridge rectifier. If you're doing AC voltage, you'll need a bridge rectifier. You'll have to have that. If you're doing electrolinks, you'll be able to do that specific connectors. You can also do an annunciator. There are plug-in annunciators. If you're doing DC voltage, you won't hear a buzz. You can do that DC voltage with not annunciator, but a buzzer, so to speak, if you want to be able to hear the strike being energized so that you can pull it open. That's a 2006M is that part number. Different finishes. You can do this in all of the different architectural finishes. 605 for bright brass, 606 for satin brass, 612 for satin bronze, 613 for a bronze toned, they call it. Oil rubbed is the 613 version. They can do a powder coated version of 613E, which will be a stable, uniform, dark bronze powder coat. 629 for polished stainless, 630, of course, for satin stainless, which is the item that you see here. So all of those different options. There are no alternate faceplates because there's only one application. And last but not least, this is intended for with exit devices with a Pullman latch. It has to be a triangular shaped Pullman latch, and if you're not sure if what you have is a Pullman latch, locate the definition of Pullman latch, confirm that visually what a Pullman latch is what you have on your device. Up to a 3/4 inch throw is what this will account for. So at that point, we've covered all of the particulars of this strike. Now, finally, there's a link below this video to the manufacturer's page where you can pull up not only all of the HES products that we sell, but a link to the manufacturer's website, as well as a link to the full product catalog where you can review all things HES strike. I'm partial to HES. They fit in that mid-ground of, like I had said initially, not too expensive, but still very good, high quality. They are a part of the ASSA ABLOY, at least currently, fleet of companies. Folger Atom is their sister company who makes the rock-solid, top-of-the-line electric strikes. When you need a strike that will take the most abuse possible, Folger Atom would be a manufacturer that I would suggest you look at initially. HES, in my experience, seems to fit, certainly grade 1 rated, but when you need something that's going to be more substantial, look to Folger Atom. But when it's not as heavy duty or as potential for vandalism, break-in, abuse, HES is a great option. I find that their customer service department, as it also is with their sister company, Adams Wright, exceptional. Securitron, exceptional. Really responsive, prompt, reliable, predictable, the right answers, etc. You can't really ask for much more when it comes to the people that you're buying your hardware from. If you have any questions on the HES 9500 electric strike for rim-mounted exit devices or any other HES product, please feel free to reach out to us. And thank you.